QuantumScape was started 14, 15 years ago with a desire to give the world a significantly better battery. And it's that significant powertrain advantage in the growing EV segment that attracts OEMs to our solid state lithium metal technology, because there's an opportunity for your vehicle to significantly outperform on all of the dimensions that are important. If we have speed, if we have innovation, and we have partner enablement, we expect to win.
Welcome to the show, Kevin. So how are things?
Things are great. Talking to you today from the sunny Bay Area, right in the heart of Silicon Valley.
Yeah, lovely. Weather sounds a lot nicer than what we've currently got. I'm based in the UK, in London, just by Liverpool Street, if you know it. And yeah, it's getting into evening time.
I studied for 6 months between the University College of London and LSE. I was kind of near the King's Cross station. Love London. I actually grew up in Oregon, so I'm used to that weather vibe, though I have opted differently for the rest of my life being here in the Bay Area.
Yeah, well, that's completely understandable. All right, well, let's get into the thick of it. I want to just help, I suppose, any listeners that are unfamiliar with QuantumScape to get a better understanding of what you do and your product offering. So give us a sense of what problems you're solving and how solid-state lithium metal cells change the EV equation.
It's a wonderful question. Batteries are a massive economic opportunity. If you think of automotive alone, the global market size in 2025 is something like $90 billion. I'm quoting Bloomberg New Energy Finance, who's one of the more thoughtful forecasts out there. That's forecast to grow to between 300 and 400 billion, more than 3x over the next 10 years. That's automotive alone, and that's still only at about half penetration. So if you layer on all of the other applications for things that use battery today, and you start to add in things that don't use batteries but would be a better product if they did, it's truly one of the largest economic opportunities out there, which is energy storage. QuantumScape was started 14, 15 years ago with a desire to give the world a significantly better battery. For us, that means changing the type of chemistry that's used from lithium ion, which we use today, to, as you mentioned, what's called solid state lithium metal. And I'm happy to go into some of the chemistry and link to the performance advantages if that would be helpful.
Yeah, absolutely. I think we can come back to that. Yeah, I'm sure our listeners would be really interested to hear more there. I think before we do though, let's kind of introduce you to the listeners, having introduced QuantumScape. So I think you joined more than a decade ago.
That's right.
I think you became CFO in 2018. So give us a sense of the key career moments that prepared you for guiding, obviously, an R&D heavy company and a pre-revenue company towards commercialization.
That's right. I was one of the early non-founding employees, have been here more than 14 years, which has been a joy to see the journey from, does a material even exist that would enable this chemistry for the use in automotive, to just 2-3 weeks ago rolling a Ducati race bike across the stage powered by our cells. So that was a pretty special moment. So your question is, what were the experiences that well prepared you? I would have to give a shout out to back in the day, my parents. Father worked shift work at a paper mill. Mother worked part-time as a nurse while raising 4 kids. Stepfather, a pharmacist. They had genuine sacrifice for the kids to open up opportunities, and also the work ethic. That's certainly part of a startup, with that intensity and that drive and that resilience. Maybe a second thing would be the combination of a pair of early career experiences with McKinsey as a consultant and Bain Capital in private equity. As a startup, especially as a hard tech startup, to be successful, you probably need to be contrarian and right. And by definition, you're doing something that no one has ever done before. For us, commercializing solid state lithium metal in automotive. And it's basically a set of hypotheses when you start out, and being honest about what they are and what the largest ones are, and just relentlessly driving at those, and adding structure to something that's ambiguous. I would credit those experiences. And then the final block, I did a joint degree at Stanford, an MBA and a master's in science through their their interdisciplinary environment and resources joint degree program. And then at QuantumScape, I've been here 14 years. I led product management for the first 6 or 7. I've done operations management, all of marketing, finance, and IT currently. And having worn those hats for portions of time helps me understand the different challenges and opportunities from different perspectives, and to help more effectively work with my colleagues and to try to make better holistic company decisions in my role as CFO.
Yeah, fantastic. I think that's really useful context, and obviously an exciting journey so far. I just want to pick up on that milestone. You mentioned the Ducati race bike on stage at the recent event, which we'll go into in more detail soon. Give us a sense of what that demo validated. Give us the kind of context around that milestone.
So it was an emotional moment. There were many of us there to see that Ducati race bike powered by our QSC5 cells. As I alluded to, when we started out, it wasn't clear if a material existed, if that material could be made thin and continue to function, could be made larger, multi-layered, could be made continuously with no applied pressure, with no excess lithium. All of these things were generally thought to be at least difficult, if not outright possible. And it took going through all of those things to get here. So there's still a lot of important work to do, but nonetheless, to power a vehicle in the very bright spotlight of the Munich Auto Show was a very proud moment. And it also really embodied the wonderful partnership we've developed with the Volkswagen Group. Thomas Schmal, board member, head of all group technology, was on stage when that black blanket was pulled off the V21L Ducati race bike to debut their first solid state vehicle ever demoed in the group. The pack was done by Audi. The bike was done by Ducati, and QuantumScape, together with our partners PowerCo, provided the cells. And you asked, in addition to being a milestone, it was also the first time our cells have been integrated into a module, into a pack, and into a vehicle. And I would say every single party that I just mentioned learned from that experience, and you'll see those learnings show up in the next set of milestones that we do together.
Yeah, fantastic. It sounds like a real point of validation then. I think then let's move on to kind of what's to come. I mean, obviously that was a big milestone, but talk to us about the next steps and the next milestones along your joint roadmap.
So in that same Monday event at the Munich Auto Show, Thomas Schmal laid out very clearly what the 2 next steps are towards the longer term goal. The 2 next steps is to take that Ducati race bike and put it on the track. QuantumScape, our no compromise solution across significantly better energy density, much higher power, which especially shows up in charge time. These QSC5 cells that we held up and kind of told the world about last October when we started B sample qualification of them, have the ability to charge in 12.2 minutes between 10 and 80% while pushing the frontier on energy density and safety. There's no finer platform and field testing context than a Ducati bike on a racetrack. So that's one of the 2 milestones that's ahead of us in 2026. The other task that we need to do is to take our prismatic cell, and Volkswagen would like to put it into a larger prismatic can so they can use it more universally across their brands and models as part of their standardization that they're seeking to do across their broader group. And those 2 steps are consistent with our long-term goal of series production of our solid-state lithium metal battery technology with PowerCo before the end of the decade.
Yeah, okay, yeah, I saw that VW flagged a goal to enable that commercial solution by the end of the decade. So that's great. Is there anything you'd like to add in terms of what internally you deem or will deem success by that end of the decade point?
So certainly success will be tactical goals in the year we talked about on the Q2 earnings call. One of them that is outstanding, which is important, is to bring up the rest of our pilot line here in San Jose. I'm actually sitting in our San Jose building number 2, which has our pilot line, which we're bringing up together with Volkswagen's PowerCo.
Mm-hmm.
Having hit a major milestone in June was to move to our very fast separator process, which we call Cobra. All of the downstream equipment we're upgrading as well to keep up and to also introduce higher degrees of particle control and automation. That's key for a few reasons. One is it produces parts for other demos and learning, which we'll do. Having brought up the line jointly together, it's one of the tasks of the group to create a blueprint that Volkswagen can then use when we transfer the technology into their factories. So tracking to those milestones, making Volkswagen successful, certainly at the top of the list. More broadly, from a corporate perspective, we aren't a single customer company.
Mm-hmm.
Success would involve striking similar magnitude deals as what we've done with Volkswagen PowerCo with other OEMs. We are a technology licensing company. I'm sure we'll talk more about that in the business model later. But replicating that type of deal structure with a certain cadence is important. The other 2 things I would highlight is, as a technology licensing company, we need differentiated cell performance, and we need to create that, and we need to keep replicating it. So I would continuing down the roadmap and reestablishing and broadening that differentiation. And the final thing is broadening the QuantumScape ecosystem. Our goal would be for a cell manufacturer who's licensing our technology, be to have a turnkey solution with the world's finest partners they can use, for example, to source our unique ceramic component that enables the chemistry we've discussed. In the last year, we've announced collaboration agreements with both Murata, based in Japan, and Corning, based here in the United States, who are arguably two of the premier global ceramics partners you would want in your ecosystem.
Yeah, absolutely. Well, you touched on the kind of broader OEM interest then, and that was signaled at the event. Really interesting sentiment coming out that event. Can you give us maybe a kind of less abstract idea of, the actual problems that other prospects are looking for you to solve, and do any kind of application examples spring to mind?
So I'll start with automotive, which is our focus. And from an OEM's point of view, and our first target will be the performance segment of the very broad automotive market. It is Volkswagen has some of the most iconic brands in the world, between your Porsches and Audis and Ducatis and Bentleys, etc. They also have volume brands like Volkswagen, Skoda, etc., commercial trucks. So a wonderful partnership we've developed with them over the last 10 years. It's not, taking a broader perspective, it's not common that you see a significant powertrain advantage when, for example, an Audi or a Porsche would go up against a Mercedes or a BMW. And it's that significant powertrain advantage in the growing EV segment that attracts OEMs to our solid-state lithium metal technology. Why? Is because there's an opportunity for your vehicle to significantly outperform on all of the dimensions that are important. As from an EV driver, you want range. That turns up in terms of energy density, where our QSE5, 844 watt-hours per liter, 301 watt-hours per kilogram. What that means is that you can put more range in the same vehicle footprint without changing the rest of the car. Charge time, I mentioned 12.2 minutes, 10 to 80%. That's about half what my Tesla Model Y does today. Improved safety. In enabling the solid-state lithium metal chemistry, we've removed 2 of the 3 organic materials from the cell that would contribute to fire and a safety event. That improves safety. And then the other 2 would be life and cost. So life, as manufactured, we do not manufacture an anode. That's the key benefit of a lithium metal cell. We eliminate the graphite silicon that hosts the lithium ion, hence lithium ion chemistry.
Mhm.
And in doing so, that enables the other dimensions that I discussed, but it also eliminates one of the sources of life loss. So you see greater capacity retention over life. And finally, cost. This is where it's beautiful, and that all those performance advantages come from not manufacturing one of the two electrodes. So it's by removing material and the associated transformation cost that by itself improves the cost of the cell, and it's on us for the ceramic component that we make to make that cost competitively, so the whole cost of goods sold is advantage. And that's something that we target and that we believe will be the case as we hit maturity and scale.
Yeah, absolutely. And perhaps we've already touched on it, but keen to kind of hone in on QuantumScape's moat. Is it the ceramic component? Is it the anode-free architecture that you just referenced, your manufacturing know-how? What's the hardest thing to copy?
It's a great question. And all of those things that you mentioned, the materials, the process, the architecture, are so tied together that when you change one, you end up tweaking the others. I'll give you two ways to look at it. One, if you think about it from the broader perspective, and we publish this in our investor facing deck, which is right off our website. We plot everyone's prototype performance for lithium metal batteries because we think that's disruptive, and it's a helpful point for investors to know what have folks actually shown in their chemistry. We're the only ones who've shown what we think is automotive type performance, which we define as 800 plus cycles to less than 20% capacity degradation at reasonable pressures and temperatures with 1 hour charge and discharge. With no excess lithium. Those things together, no one else has done. And in fact, everyone is off by multiple dimensions. What's key to that is an understanding of how does lithium metal plate in an automotive context, and there's many choices. What material do you use? What processes do you use? And if you combine all those things together, what's the problem you're solving? What's the material you're using? What's the set of processes? It's a combinatorial, very large space, which is why it's been so hard to solve. So that's it's really the iterations over the last 14 years going through that with those interconnected variables, combining unique skill sets and people together. And I would also argue that it has to be done under one roof. I don't think you could do the component itself without having a broader understanding of the rest of the cell. So I think that's been the key to success for us. And just as evidence of that, as we went from batch production to continuous production to faster continuous production to even faster continuous production going through Raptor and Cobra, we were making tweaks to the architecture and to the materials at every step along the way. I don't think there's any shortcut through that type of iterative problem solving. And just as a final comment, in terms of intellectual property strategy and protecting it, we keep as trade secrets the things that can't be reverse engineered when you've take one of your cells and investigate it. Anything that can be reverse engineered, we file patents against because we've been first to the show. We have over 300 patents and patent applications.
Yeah, fantastic. Well, I think that leads me on to my next point then. QuantumScape are doing a ton of fascinating, interesting things. But I guess on the flip side of that, how do you decide what to hone in on? What parts of the battery value chain should you own directly versus where does it make sense to pursue a capital-light licensing approach?
So not this summer, but the prior summer, we made an important decision to become a technology licensing company. And along with that decision, we announced VW PowerCo as our anchor tenant. The prior strategy was as a joint venture, similar to it, but not the same. It would have had greater capital intensity. We went from a joint venture to that technology licensing model where our core deliverable is intellectual property to our partners. Why did we make that choice? A few reasons. One is that is what we are good at today. We have shown, I think, very impressive results out of our QSE5. We're very proud of the roadmap, the process, the tools, the materials, the supply chain. That's our core competency today. A second, from the point of investors, is that it's very capital efficient. When we announced that, we said that we removed the equivalent of $500 million from our roadmap in terms of the need to raise money. That came from a combination of things, eliminating the need to invest in a factory, new inflows from Volkswagen in the form of the royalty prepay, and also because of the contribution of PowerCo resources and us needing to do less, actually lower expenditure from us as a company. So that capital light nature we think is important. And then if you fast forward to this summer, we expanded that deal. That deal was up to 80 gigawatt hours. It's about 1 million vehicles. That's a massive deal with one of the world's preeminent automotive manufacturers, kind of the anchor tenant of the ecosystem. What's neat about this expanded deal is that now there's, in addition to that 130 million royalty prepay, there's also an opportunity to earn up to $131 million of collaboration payments, where Volkswagen is paying us to do custom development specific to their asks. So from an investor point of view, instead of waiting for the technology to ordering the equipment, the factory to start up, yields to improve, and then off to the races, there's an opportunity for cash flows now. We said in the most recent Q2 call that the goal was in Q3 to invoice for the first time in our history. We talked about approximately a $10 million invoice. So pulling forward to the immediate moment a customer paying us for the technology development is a very kind of potent thing, and a nice signal for investors that what we're doing is important. And I'll use the opportunity just to take a step back, that we've kind of painted in one of the two cash flows for investors, which is that payment from OEMs during the collaboration phase of the business. The second, of course, is once the license is granted. That's in the licensing portion. That's where the bulk of the economic opportunity is. So the goal of the company with those two opportunities for cash flow be to strike a set of these style of deals where there's significant potential cash flow in this collaboration phase. That can be a very powerful offset towards our kind of core expenses as a innovation-focused company. And then longer term with those licensing payments, there's wonderful operating leverage in a licensing business model. And you can think of it, so our CEO, Dr. Siva Sivaram, comes from the semiconductor space, and we're effectively trying to take a page out of that playbook, where you have fabless design companies like NVIDIA, dedicated manufacturers like TSMC, and specialized ecosystem players like ASML making components. We're trying to replicate exactly that here in the battery space. You have QuantumScape on the innovation side, PowerCo is an example on the cell manufacturing side, and Murata and Corning in those ecosystem type roles. So we're literally trying to take a playbook right out of the semiconductor space.
Yeah, fantastic. I think that's a really useful analogy. And I think that's a nice segue then to talk about more explicitly the financials. I read that you extended cash runway into 2029. So what assumptions underpin that? Is it the PowerCo milestones you've referenced, operating cost trajectory, or additional collaboration inflows perhaps?
So the first part of your question, yes, and the second part of your question would be upside. So it's the in Q2, the roughly $800 million of cash and marketable securities. The expanded PowerCo agreement is an input into that cash runway calculation. Any further deals with other OEMs or any expansion outside of automotive, that would all be upside to that forecast and incremental cash.
Fantastic. Okay, well, let's have a look at how that translates to the share price. So, I looked before the call. I think QS shares are up around 179% year to date. So fantastic growth so far this year. Give us a sense of what's driving that momentum in your view, and what milestones should dictate the narrative from here on in.
A great question. If you look back, it was almost a year exactly, because we're in just the earnings call will be upon us soon, or perhaps by this film we'll be just on the other side of it. That's when we talked about the QSE-5 cell. So that the first kind of B sample of a new technology is a very big product development milestone. So that started the last year. And if you think about what we've accomplished, in June we went from our Raptor process, which was an 8x improvement over our prior continuous process, to our Cobra process, which is an incremental 25x. So that was a big milestone. It's not enough to have high-performing cells, you need to have a method of making at automotive scale that we think can scale the rest of the way. That is Cobra. We expanded the Volkswagen arrangement. It went from 80 to 85 gigawatt hours. We added that $131 million of collaboration payments. VW got the right to certain Gen 2 technology, as well as the ability on that last 5 gigawatt hours to sell it outside the Volkswagen group, and that isn't limited to any application. We announced partnerships with both Murata and Corning, a very key ecosystem additions. And as we discussed, our QSE5 cells powered a Ducati race bike across the IAA Munich stage. So it's been one heck of a year in terms of execution. Looking ahead, I would look to us to go after the rest of the goals in 2025 that we alluded to on the Q2 call. That would be successfully installing the key production, the key cell production equipment with PowerCo to bring up the rest of the line, to continue to work on expanding commercial relationships, as well as the first B1 sample shipments using our Cobra cells. And more broadly, as we alluded to, making Volkswagen successful, striking other similar deals with other OEMs, fleshing out the rest of the roadmap, and continuing to work on the QS ecosystem. I think those would be the major categories of catalysts I would look to.
Yeah, fantastic. I think you've given us a nice kind of overview. And having covered the bull case, I suppose, to use the sort of investment speak, let's have a look at the risks, if you could play devil's advocate for a second. Perhaps you can give us up to 3 execution risks from here and your mitigations to those.
So if you look back to what I said were things to do, bringing up a pilot line, taking something from a prototype, getting it to the point of transfer, and then supporting our partners doing that transfer is the task. I think the things with that would be, what does it mean to industrialize? I think you'd point to things like yield. I think you'd point to things like supply chain. And I think you'd point to IP protection as being some of the big 3. So yield, what does that look like? It is very non-sexy engineering. You Pareto out what are the sources of yield loss. You define, you measure, you analyze, you improve, you control, you rinse, repeat. Siva talks about being systematic, methodical, and iterative. There aren't shortcuts. You just do it over and over and over again. Siva, wonderful CEO, has taken, I'll use some liberties, call it a dozen technologies across semiconductor and data storage and solar, from prototypes into production, into mass market. All of those learning curves that you see, technology after technology after technology, you see them, but they don't come down by themselves. It's that iterative type of engineering work in the background. It's difficult work, it's challenging work, but if you persist at it, that's how you create the learning curve. Supply chain. So it is a new component. It has materials, it has equipment. How do we de-risk that? So one path is, which we do, well, there's one precursor and then one mitigant. We've mentioned before that we've settled on a separator that can both meet performance requirements, but it is also made of earth-abundant materials whose producers are found on all the major geographies across multiple different players. That's an important way to start. And then we work with multiple players, many of the who's who of that sector. The number has advantage, both as a portfolio effect, but they also have slightly different approaches with how they would scale it up and bring cost and automotive quality as volumes ramp up. And then the third, which is IP protection. So it is somewhat contrary to IP protection to go into a licensing model. By definition, you are teaching a select number of partners your special, your trade secrets, which are very hard to otherwise reverse engineer. So the strategy there is to align incentives very well to make sure that there's a very attractive business model available for both us and our partners, so that they have the same incentives we do to both care for the intellectual property and for what we jointly protect together to protect it, as well as all of the contractual boots and suspenders. And there's also a sweet spot with a number of partners. We want some choice for our cell manufacturers, but also we want it limited to not overly do that diffusion type risk.
Yeah, fantastic. Well, I appreciate that's harder to do than outlining all of the exciting kind of bull case scenarios. So I appreciate that really objective analysis. And kind of whilst I think you referenced learning curves a couple of times there, whilst we're
Yeah.
thinking with that mindset, if you could rewrite one assumption that you held, say, 2 years ago about solid state commercialization, what would that be?
So 2 years ago would have been 2023. For me, I mentioned that startups are all about, or early kind of pre-commercial companies are all about hypotheses. For us,
Mhm.
we had a hypothesis, which was, can a licensing model be successful in this energy storage type space? So that was certainly something that was a question mark that we put a lot of evidence against. With the VW PowerCo type deal and the attraction of the ecosystem partners. And more broadly, there is a funnel in the background that we've discussed about with many other OEMs who are interested in that type of model. And we think in a very competitive world that is dominated by a small number of Chinese lithium-ion manufacturers, that focusing on a differentiated product and stacking the strengths of global partners to both achieve scale and both the scale of output as well as scale of development dollars, we think is a very effective strategy. That if we have speed, if we have innovation, and we have partner enablement, we expect to win.
Yeah, absolutely. Okay, well, I think that's a nice sort of penultimate insight then. And for anyone that's listened to the podcast before, the question that we always end with is to ask our interviewees what their next big idea in their particular field is. So our tagline is invest in the next big idea. So if you could just highlight one product, technology, or even innovation, regardless of how niche, within your space, what would it be?
I'm personally really excited about battery recycling, and as well as how solid state lithium metal will help accelerate it.
Mm-hmm.
If you think about it, batteries are pretty special. At the end of automotive life, you should take them out. You should go find a second application, go use them in a second application like the grid. At the end
Mm-hmm.
of that life, say you choose to recycle it, all of the materials that you put into the battery are still there. So you should be able to take it and to pull out those valuable materials. And over time, with penetration, as ultimately more and more things, as more packs come to end of second life, say, first some, and then more, and then most, and then substantially all of inputs to make more batteries should come from recycling. So the dependency on mining and pulling things out of the earth should dwindle down, and that's a very powerful. That's a very powerful concept in terms of a true closed loop, secure supply chain that's also sustainable. So that is, I'm very excited about, and an area where solid state lithium metal batteries can accelerate that. Those that are no excess lithium as we make. It turns out one of the most dirty components to make when you make a cell is the anode, that graphite and silicon. And it's also one of the dirtiest and least economical components to recycle. In fact, many approaches burn it. So we have no anode, so it's only the separator, which we think you can extract and reuse, either grind it up or recapture the materials, as well as the metals and the foil. So more of what you economically want is there. So that's, I think, a wonderful end state that we hope to accelerate.
Yeah, absolutely. I think a really illuminating next big idea, on which I think we can end the podcast. I mean, it just leaves me to say thank you very much for joining us on the show, Kevin. It's been a real pleasure.
Our pleasure, and thank you for inviting us and letting us share about solid state lithium metal batteries.